And now we get to the very, I would call it a humorous question because this is so realistic. You and Clara and 3 friends were born on March 11th. Leslie is 5 years younger than Clara, Mike is 2 years younger than Clara, and Thomas is 3 years older than Clara. Instead of asking how old Clara is, you find out that the product of their ages was 61,136 greater than the sum of their ages. This is a very realistic question. This comes up all the time when you're talking with your friends, I'm sure. Yeah. You don't ask them directly how old they are. You get them together and say, okay guys, multiply your ages together and tell me what you get. And then add them together and tell me what you get. And then create a really convoluted math question for me to solve. So, whereas the cardboard box question, I think, is a great example of where we can use this as a real-life application, this is not. But sometimes you get those math problems that are just created to practice your skills, and that's all this is. How old was Clara and each friend on that day? So what this gets us to practice is we have to set something as a variable and then set everything else up in respect to that so we can create an equation. So we make Clara x. Excellent. And then if Clara is x, how old is Leslie? X minus 5, because she's younger. Mike? X minus 2. He's also younger. And Thomas? X plus 3. Okay? On March 11th, the product of their ages was 61,136 greater than the sum of their ages. Okay. Wow. First of all, I'm going to just add these up because the sum is going to be easy to figure out. If I add those all up, can you see that I'm going to get 4x minus 4? The product would be all of them multiplied together, and I'm not going to multiply all those together. But there is a relationship here in the question between the product and the sum. We're told that the product was greater than the sum by 61,136. So what we're going to do is we're going to set up our equation. On one side, we're going to put our product. On the other side, we're going to put our sum. And then we're going to decide where does it make sense to put the 61,136 so that it's equal. So I'm going to put the product on this side of my equation. Well, what does product mean? It means multiply them all together. So I'll just write that as multiplied all together. And on this side of my equation, I'm going to put my sum. Put that in brackets too, just to keep it together. And then the question says the product was 61,136 greater. So of these two sides, which side is bigger? Right now, the left side should be bigger than the right side. So in order to make them equal, does it make sense that I'm going to have to add the 61,136 on this side? It wouldn't matter if you subtracted on the other side. That's going to be the same thing. Now we're going to look at two different ways to solve this equation. Okay? Method 1 is to keep things the way that they are and make this, type it into y1 in your graphing calculator, and type this into y2 in your graphing calculator. So if we were to do that, x, I should memorize it first, x minus 5, x minus 2, x plus 3, x minus 5, x minus 2, x plus 3. And in y2, and you could simplify, like in 4x minus 4, you could put the minus 4 and the 61,136 together, or you could just write it exactly as you see it. Your calculator knows the difference. Now, if you're on a standard window, when you go to graph this, this is what you'll see. Oh, there's a line. Whoa, whoa. And the red graph apparently isn't on this screen. So this is what could appear if you're just on a standard window. And that's not very helpful, because when you type something in one side of the equation in y1 and the other side of the equation in y2, what you're looking for is where do those two graphs intersect. And if you can find where they intersect, you're going to be able to find the solution for x. Unfortunately, right now, the way that my graphs are set up, I cannot see where they intersect. So I could play around with my window and zoom in and zoom out. You could try different things with zooming. I'm going to try zoom fit, see what that does. Zoom fit. And I'm hoping that at least I'll be able to see part of my red graph now. Oh, there it is. That fits wonderfully. So there's a problem here with trying to figure out our window. And this is going to be something that you often run into problems, is trying to figure out what window makes the most sense. Well, considering Clara's probably not -7 years old, okay, considering the context of the problem will also help us. So I'm going to go to my window and say, well, it probably doesn't make sense for me to go too far into my negatives, because Clara's probably not -years old. So if I start at -1, and I'm guessing she's not super old, but just to be safe, I'm going to go up to 100. And then look at what happens with that graph at that point. Oh, it looks like my blue graph goes way up. Can I still see my red graph? No. Oh, almost. Okay? So to adjust things here, my blue graph, which is an x to the 4 graph, is going up super fast, super quickly. It looks like going all the way to the 100 is a little bit extreme. So I'm going to go back to my window. I'm going to change my x max, thinking that probably even 40 or even less will be fine. But I am going to increase my y max. Since it was already 60,000, I'll go up another 20,000. And see what that does for my graphing. What I'm trying to do is find a place where my red graph and my blue graph cross. And now that's showing up in my window. So now I can go second, calculate, number 5, where do these intersect? Enter, 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 and x is 17. So this is method 1. Method 1. Then once you find out that x was 17, you can figure out all of these other numbers as well. And as soon as you see those numbers, I'm sure you do the mental math in your head and go, oh, obviously that the sum is 61,136 less than the product, because I can do that mental math quickly. No. Okay? The other way, if finding that intersection is hard because it could be anywhere on your screen, the other way that this question is sometimes solved is by moving everything over to one side. So I'm going to subtract 4x on both sides. And this, if I put those together, would have been 61, 132. I'm going to bring that over to the other side to make one side equal to 0. Because now if I graph this, so I'm going to go to my graphing calculator to y equals, I'm just going to turn that equal sign off. That way I don't erase it, but it doesn't graph. And I'm going to write minus 4x minus 61132. Now if I graph that, what am I going to be looking for if I want it to equal 0? I'm going to be looking for an x-intercept. So again, I haven't changed my window. I'm just going to go back to a standard window to see what that would look like. So this is probably where you would start, a standard window, and in this case, what shows up? Absolutely nothing. So we know we have to change our window. Again, in the context of the problem, we're really looking for ages, so I don't need to go too far into the negatives. And let's say you start with 100 again, because you think that would be sort of a maximum age. And then you hit graph. The nice thing about this is we're just looking for an x-intercept. Boom. Looks like there's one there. So you can go second, calculate. X-intercepts are number 2, 0. You need to go to the left of it. You need to go to the right of it. So I'm going to say 10 looks like it's on the left. 30 definitely looks like it's on the right. Is my line between those two? Yes, it is. Push enter and it'll calculate our x-intercept, and it's also at 17. Of these two methods, overall, moving forward, I find that people tend to use the put something into y1 and something into y2 more often. In this situation, finding that changing your window was a little bit harder with that. Okay? The x-intercept method is nice because you know you're looking for it along the x-axis. And especially because this was an ages one and it was reasonable to think that their ages would be somewhere between 0 and 100. That made the window part of your graph a little bit easier. So even though this is an unrealistic question with little to no real life applications for what it's asking about, the skills that you're developing within it are still good mathematical skills. The questions that are similar to these birthday ones are questions 7 and 8.